Good day. The topic we are treating today is statistics by Monserrat. This video is a continuation of graphical representation of data. In this video, we discuss the different types of bar charts and solve examples on frequency table, pie charts, histogram, and bar charts. Lesson objectives. The objectives of this video are to represent data graphically with the use of different types of bar charts and how to construct these types of bar charts, and also to solve examples on frequency table, pie charts, bar charts, and histogram. By the end of this lesson, you should be able to solve examples on frequency table, pie charts, bar charts, and histogram. Prerequisite topics, that is, topics you must have been known before you can watch this video for easy understanding. You must know about the tabular representation of data, that is, using the frequency table and the cumulative frequency table, and also the graphical representation of data, that is, the use of pie charts, bar charts, and histogram. Bar charts. Bar chart is one of the most popular type of diagrams used to show statistical information. The graph can be plotted vertically or horizontally. The x-axis represents the categories, that is, your items, your data, and the y-axis represents the frequency, that is, the frequency of those data. When you are plotting a bar chart, the bar will be separated by equal gaps. So this bar chart has three types. The first one is the simple bar chart. This one deals with a single data with its frequency. They are graphed with rectangular bars. Each bar's length or height is proportional to the frequency. That is, the frequency of a particular data equals its height on the bar chart. The graph usually shows a comparison between different categories. So now, if we want to use the information in this particular table, where we are giving data about certain foodstuffs like rice, the amount it bought, beans, provisions, meat, vegetables, and transport and garri. So we want to show this information on a bar chart. These are the data and this represents the frequency. So we'll show this on the bar chart. You can see that rice is 600, which is here. Beans is 250. We can see here we have 1, 2, 3, 4, 5. So each line represents, the first one, we are counting in hundreds from 0, 100, 200. So to determine the value of this single line, we divide 100 by the number of line, which is 1, 2, 3, 4, 5. So 100 divided by 5 is 20. This first line is 20. The second line is 20 plus 20, which is 40. 40 plus 20, 60. 60 plus 20, 80. And 80 plus 20 will give 100. So this line is 20, and in between 20 and 40 you have 30, and in between 40 and 60 you have 50. So beans is 250. You can see that this is 200, 220, 240, 260. So in between 240 and 260 we have 250. So provision is 120, which is here. Let's check. Provision is 120. Meat is 230, to be between 220 and 240. See it here. Vegetable is 140. See, this is 100. You can see the line 100, 120, 140. We'll trace it there. You can see this is 140. Transport is 260 and garri is 200. So this is a simple bar chart because we have in a we have a single bar. You can see single bar for each data. So that is all about a simple bar chart. So we move to the second type of bar chart, which is the multiple or grouped bar chart. This bar chart shows information about subgroups of the main category. We have the main category and we have subgroups of the main category. So here we have more than two bars, we have more than a bar. A separate bar represents each group. A key or legend is usually included for identification of the subgroups. The subgroups are displayed on different bars. So now we move to example. If you are to use this table, which shows the sales of two popular soft drinks between the year 1977 and 1980. So these are the years. From 1977 we have 1977, 1978, 1979 and 1980. So these are the popular soft drinks, Fizzo and Cocoa. So here in 1977 we have 50,000, we sold 50,000 soft drinks, which is Fizzo, and in that same year we sold 40,000 for Cocoa. That is how. So this is the main group, the years are the main group, and the Fizzo and Cocoa are the subgroup. So now we construct a bar chart for this. In a single year we have to have two bars, one for Fizzo and one for Cocoa. So Fizzo, the years are the main category, while Fizzo and Cocoa are the subgroups. So now we'll see how to construct the multiple bar chart. In 1977, Fizzo is 50,000 and Cocoa is 40,000. And you can see the total for 1977 is 90,000. 1978 we have 62,000 and 48,000, which gives 101,000. 54,000 and 52,000 gives 106,000. 48,000 and 60,000 gives 108,000. So now we move to the construction of the multiple bar chart for the year 1977. This is what they call a key or a legend. You can see that the color of Fizzo is blue. So anywhere you see a blue bar, it's representing Fizzo, and anywhere you see a peach bar, it's representing Cocoa. So this is Fizzo bar and this is Cocoa bar for the year 1977. So in the year 1977, Fizzo is 50,000, which is here. You can see the line for 50,000 is here, and Cocoa is 40,000. So this is 40,000 here. So before you start this, you first calculate the value of each of those small lines. We can see that here we count in 10,000. The first we count in 10,000. So look for the value of this first line. Between here and 10,000 we have 5 lines, which is 1, 2, 3, 4, 5. So to get the value of this small line, which I have explained earlier, we divide 10,000 by 5, which will give 2,000. So this first line is 2,000, the second line is 4,000, the third line is 6,000, the fourth line is 8,000, and 8,000 plus 2,000 will give 10,000. So each of this line is 2,000. So for the year 1978, Fizzo has 62,000 and Cocoa has 48,000 sales. So Fizzo has 62,000, so you start from 60,000, 62,000. You can see that each line is 2,000, so 60,000 plus 2,000 will give 62,000, which is this line. We trace it here. You can see this is Fizzo for the year 1978, and Cocoa is 48,000. So we start from 40,000, which is here. 40,000 plus 2,000 plus 2,000 plus 2,000 for 4,000 for 6,000 for 8,000. So if you trace this, you can see that is Cocoa for the year 1978. and we do the same thing for the year 1979 and 1980. So this year are the main group, and this Fizo and Cocoa are the subgroup of this year. So that is what I said. Multiple bar charts shows the main group and the subgroup. So this is what we call a key or a legend for you to know what we are talking about. Fizo is color blue and Cocoa is the peach color. So that is all about a multiple bar chart. So we move to the third one. The third one is the components or stacked bar charts. This also shows subgroups, but the subgroups are displayed on the same bar. So the difference between the multiple bar chart and the component bar chart is that in the multiple bar chart, the subgroups are shown on different bars. But in the component bar chart, the subgroups are shown in the same bar, but it's only the key or legend that will differentiate them on that particular bar. So now we also need a key or legend. I've explained the meaning of a key or legend. So now we use the table below, that is the table for Fizo and Cocoa, to also construct a component bar chart. So here you can see in the year 1977, we already know the total is 90,000. Here we first calculate the value of each line. We count in 20,000s. So we divide 20,000 by 5, which will be 4,000. So each of this line is 4,000. 4,000 plus 4,000 we give 8,000, plus 4,000 we give 12,000, plus 4,000 we give 16,000, plus 4,000 we give another 20,000. So here, if we sum 5,000 and 4,000, which is the total in the year 1977, we have 90,000. So the line 80,000 is here. So the line 80,000 is here. So 80,000 plus 4,000 we give 84,000. 84,000 plus 4,000 we give 88,000. 88,000 plus 4,000 we give 92,000. But we are looking for 90,000. So that 90,000 will be closer to 92,000. That's why you can see that there is a little space between the line of 92,000 and where that 90,000 is drawn. You can see that it's closer to 92,000. So this is it. Now we divide them into their sections: 50,000 for Fizo and 40,000 for Cocoa. So here, this is 40,000. We first start for Fizo, 40,000 here, 44,000, 48,000. Just add 2,000, which is half of this line. Between this line and this line is 4,000, so we divide them into half. That is why we have Fizo here. We paint it in blue, and we start from here again. We have 2,000 remaining here. 2,000. So 2,000 plus 4,000 we give 6,000. 6,000 plus 4,000 we give 10,000. Plus another 4,000 we give 14,000. Plus 4,000 we give 18. 22. 22 plus 4 we give 26. 30. 34. 34 plus 4 we give 38. And here we have 2,000, which we give 40,000 for Cocoa. So that is how to construct a component bar chart. So for here, we also do the same. We had the total. We first look for the total of 1978, which we give 110,000. So this is 100,000 here. Consider 100,000 is here. 100,000 is here. Each line is 4,000. 100,000 plus 4,000 we give 104,000. Plus another 4,000 we give 108,000. So plus another 4,000 we give 112,000, and we know that we are looking for 110,000. So it's going to be 2,000 plus 108,000, which is the difference between this line and this line. So we divide this line into two equal parts and we take the 2000. So if you trace the middle of this line, you can see that it is equal to the total of 1978, which is this. So now we already have the bar for 1978. Now I want to divide it into FISO and COCO. So FISO for the year 1978, the sales of FISO for the year 1978 is 62,000. So we start from here. This is the line for 60,000. This is line for 60,000, and you know that 62,000 will be 2,000 plus 60,000, which will be between this line and this line. That is, if you should divide this line, the 60,000 line and the 64,000 line into two equal parts, we have 62,000. So this middle will be 62,000. If you should trace it, you can see that this is FISO and the rest will be for COCO. So we apply the same method to the year 1979 and 1980. So for FISO we paint it blue, and for COCO we paint it peach. So that is what a key or legend is used for you to differentiate where FISO is stopping and where COCO is stopping. So that is all. That is that on component bar chart. So now we move to examples on pie charts, frequency table, histogram, and bar charts. So example 1. In the first example, we are given a table, the marks of some students. So 2 marks, 3 people add 2 marks. That is, you can see that here, if you should read the table, 2 marks, you can see this column, this row is for mark, and this row is for the number of students that has this mark. 3 students add 2 marks, a single student add 3 marks, 5 students add 4 marks, 2 students add 5 marks, 4 students add 6 marks, 2 students add 7 marks, and 3 students add 8 marks. So from the question says, from the table above, if the pass mark is 5, that is, anybody that has 5 and above passed, how many students failed the test? The pass mark is 5. That if you have 5, you have passed. So if you have 6 also, it means you have passed. But if you have anything below 5, that means you failed. So how many students failed the test? We have to calculate the number of students that failed the test. This is a UTME pass question, UTME 2010. So score booster solution. Since 5 is the pass mark, then the marks of those that failed the test will be the marks less than 5. That is 2 marks, 3 marks, and 4 marks. So now we calculate the total number of students that failed, which will be the sum of students that has 2, 3, and 4 marks. So the number of students that has 2 marks is 3. The number of students that have 3 marks is 1. And the number of students that had 4 marks is 5. So now we add it together, which is 3 plus 1 plus 5 students. So 9 students failed. If 5 is the pass mark, that means 9 students failed. Therefore, the number of students that failed the test, if 5 is the pass mark, is 9. So that solves the question. That is how to interpret a frequency table. So now we move to the second question, which is question 2. This is also a question on frequency table. It is also a question from the UTME 2010. So we are also given a table of students that took tests and has marks. So for a single mark, that is 1 mark, the frequency is 2. That means 2 students has 1 mark. 2 students also has 2 marks. 8 students has 3 marks. 4 students has 4 marks, and 4 students also has 5 marks. So they said how many students took the test. We can see that 2 students has 1 mark. So the total number of students will be equal to the sum of all the frequencies, because if 2 students has 2 marks, that means we know that there are 2 students in that class plus 2 students that has 2 marks again, making 4. 3 8 8 students has 3 marks, so 8 plus 4 will give 12. 4 students have 4 marks, 12 plus 4 will give 16, and also 4 students have 5 marks. 16 plus 4 will now give 20. That is why we said the total of students will be equal to sum of all the frequencies. So which will be 2 plus 8 plus 4 plus 4, which is 20 students. Therefore, 20 students took this test, but the frequency of the mark are represented on the table, on the frequency table. So that solves the question. That is how to interpret a frequency table. So now we move to the third question. Third question is on a bar chart. We were given the number of cars on the vertical axis, which is the y-axis, and the colors of cars on the x-axis. So to interpret this bar chart, we can see that yellow cars, color of cars, number of cars. We have 3 yellow cars. You can see that the bar is stopping at 3 for yellow car. For white car, the bar is stopping at 4. That is, we have 4 white cars. Here we have 8 red cars. We have 2 green cars. 6, you can see where the bars are stopping. We say the length of the bar or the height of the bar is proportional to their frequency. You can see 6 blue cars and 2 black cars. That is how to interpret the bar chart. Wherever the bar is stopping, that is the frequency of that data. So here the question says the bar chart above shows different colors of cars passing a particular point of a certain street in 2 minutes. What fraction of the total number of cars is yellow? This is also a UTME past question, UTM 2001. So before we can know the fraction of the total number of cars, we must first find the total number of cars that pass that particular point in that street in 2 minutes. So for us to find the total number of cars, as we did in the previous example, we had the frequency of each color of car, which will be 3 plus 4 plus 8 plus 2 plus 6 plus 2. So after that, we now take the fraction of yellow cars. The reason why we are adding is that these cars that has these colors pass separately, but we grouped them into different colors, because yellow color, we saw 3 yellow cars that passed. We saw 4 white cars that passed. They will pass differently. So for us to know the total number, we have to add the height of these bars, which is equal to their frequency. So now we move to the solution. We know the number of yellow cars is 3 from the bar chart. The number of yellow cars is 3. So now the total number of cars equals the sum of the height of each bar. That is the frequency, as I've explained. So the total number of cars will be 3 for yellow, plus 4 for white, plus 8 for red, plus 2 for green, plus 6 for blue, and plus 2 for black. And that is what we have here. If this is evaluated, we have 25 cars altogether. So 25 cars passed at that particular point in 2 minutes. So we want to look at the fraction of the total number of cars that is yellow. So that will be number of yellow cars divided by total number of cars. So the number of yellow cars from the bar chart is 3 divided by the total number of cars we just obtained, 25. So the fraction of cars that pass that particular point that is yellow in color is 3 over 25. So that solves the question. So now we move to the fourth question. The fourth question is on histogram. So this particular question shows the ages of the victims of pollution. So we are asked to find the number of people that were involved in the pollution. So this is what we have been discussing. So people of age 10, is only 3 people that are of age 10 that are affected by the pollution. 4 people of age 20, you can see we are reading the height of the histogram. 30 people of 5 people of age 30, 6 people of age 40, and 2 people of age 50. So for us to know the total number of people affected by pollution, we have to add the frequency of those ages, which is the height of those bars. So the total number of people involved in the pollution is given as the sum of all the height of the bars in the histogram. That is 3 plus 4 plus 5 plus 6 plus 2. So if this is evaluated, we have 20. So therefore, the total number of people involved in the pollution is 20 people. So that solves the question. If you are given an histogram or a bar chart and you have to find the total number, you know that the frequency of those data is proportional to the height or length of the bar. So the fifth question is on pie chart. We're given a pie chart. We're given a pie chart with different foodstuff, beans, millet, maize, and other crops. So we know the angle, the sectoral angle for others is 60 degrees. The sectoral angle for maize is 90 degrees, as we have it here, the right angle. The sectoral angle for millet is 150 degrees, but we don't know the sectoral angle for beans, and we know that the total angle in a circle is 360 degrees. So to obtain the sectoral angle for beans, we'll add this together and subtract it from 360 degrees. So let's move to the question. The pie chart above shows the distribution of crops harvested from a farmland in a year. If 3,000 tons of millet is harvested, what amount of beans is harvested? This is the UTME past question, UTM 704. So score booster solution. We first obtain the sectoral angle of beans, which I have explained earlier. So since we know that the sectoral angles of all the crops, that is, all the crops in a circle equals 360 degrees, which is the total sum of angles in a circle, then the sectoral angle of beans alone will be 360 degrees minus sectoral angle of the 3 other crops, which is others plus maize plus millet, which is 360 degrees minus 150 degrees plus 60 degrees plus 90 degrees. So this will give 300. 360 minus 300 will give 60 degrees. So the sectoral angle of beans is 60 degrees. But we don't know the total amount of crops harvested. So we must find the amount of beans harvested, we first obtain the total amount of crops harvested. And you know, in the question, we were given the amount of millets harvested in that particular year, and we know its sectoral angle. So to find the total amount of crops, then we'll use the formula for obtaining sectoral angle of millet. Since we know its sectoral angle and we know the amount of millet harvested, so we use the formula for obtaining the sectoral angle to obtain the total amount of crops harvested. And you know, when we want to obtain the sectoral angle of a particular data, it will be the amount of that data over the total amount, that is the total frequency, times 360 degrees. So now if you want to use the formula for sectoral angle of millet, to be sectoral angle of millet equals amount of millet over total amount of crops times 360 degrees. But we all know the sectoral angle of millet to be 150 degrees, which will be equals to amount of millet as told in the example is 3,000 over the total amount of crops, which is the unknown we are looking for, times 360 degrees. So we make total amount of crops the surrogate of formula, that is total amount of crops will now be 3,000 times 360 divided by 150. So if this is evaluated, we have 7,200 tons. So in that particular year on that farmland, the total amount of crops harvested is 7,200 tons. So since we now know the total amount of crops harvested and we know the sectoral angle of beans, we now use those information to obtain the amount of beans harvested for that particular year. So also we use the formula for sectoral angle. The sectoral angle of beans will be equals to amount of beans over total amount of crops times 360. So the sectoral angle of beans is 60, which is amount of beans, which is the unknown, divided by total amount of crops, which we just obtained to be 7,200 tons, times 360. So now we make amount of beans using the formula, so which will now be 60 multiplied by 7,200 divided by 360. So if this is evaluated, we have 1,200 tons. Therefore, the amount of beans harvested in that particular year on the farmland is 1,200 tons, and that solves the question. So this is where we stop for this particular video. We solve more examples in the next video. Next video will be more on statistics, that is more examples on tabular and graphical representation of data with sample questions and solutions. Please subscribe to our YouTube channel, like and share our videos. Thank you.